This is Nathan Schubert presenting my final project lab, Lab 9 for ENME 351. So for my lab, I basically modeled it off of like these water speakers here, I'll show. So they react to the music and have the colored lights and the water splashing out. So I sort of designed a circuit that would mimic this behavior. So the actual circuit I designed has the stepper motor and these LEDs that light up, and it's all activated by this sound sensor that senses the music playing next to it. And so I have the the stepper motor basically operates is that when it hears a sound, it'll twist a little bit, and this would simulate power going into the speaker to shoot the water up, which if I were doing this full project, my idea is that I would like use this motor to power a fan that would a high power fan that would blow the water up when it gets a spike in the music. And these LEDs also light up when they hear music, and they kind of fade from the middle out, which is how I would want to design the lights to also react. So looking at my Arduino code, I use a lot of principles that we used in earlier labs this semester. And I started off by just defining all these variables. Noise is going to be the noise sensor value. I have all these brightnesses for the LEDs, and I set all the LED pins and a wait time for the stepper motor. And I said almost all of these pins as outputs for the LEDs in the motor, except for pin 7 is the input from the sound sensor. And so I thought I was getting an analog sensor actually, but it turns out to just read a high or low. But with its sensitivity, it works well for this lab. So it'll digital read pin 7, set that as noise, print that for the processing, print it to the serial monitor for processing. And then if the noise level is high, it'll make the middle light bright, the brightest, delay 75, then make the two next to it a little bit less bright, delay again, and then make the last two on the outside a little less bright. And then also, if it reads a high, then the stepper motor will rotate a little bit, which, as I said, would basically signals sending power to a fan that blows the water up in the speaker. And then after these lights have been high, it's going to leave them high for a little bit and then turn them all off. And so the only real issue that I have is that with this is that I have to run it all in this one Arduino code, so that the motor is a little bit delayed from the lights because it all runs as one. But if I could, I would use multiple different sensors in the actual speaker so that they could operate at the exact same time. All right, and then for my processing code, I define this variable j at the start, which I'll show what it is for later. And then the setup, I draw a shape that's going to look like the speaker. And then just make sure that I have the right port. And then, like we've used for a lot of other labs, it's going to say, well, the port is available. It'll read this serial monitor. And then it should only read a 1 or a 0. So I will set A1 as the data that's coming in, and so if it's high, then I'm going to have lights show up in the speaker. So processing is basically just showing what the speaker would look like when this is happening. And then else it's just gonna show that there's no lights, which will make more sense when I show the project. And then this J is just used to set the lights to different heights, as you'll see. And so I have J, the original variable, as 270, which is just going to be the tallest height of any of the lights. All right, so I have to make the music pretty loud for this to work, but here I have it all running. So yeah, as I was saying before, the lights flash and spread out with the music, as well as the processing showing what the speaker would look like. And then each time this stepper motor was rotating, it would basically be sending power to a fan that's blowing the water up in the speaker. Yeah, so if I went farther with this, I would try to build that and implement a fan into that speaker and make it work. And I guess I would try to figure out how to possibly make it work with Bluetooth, but I don't have that kind of knowledge. But that's where I would go with this project in the future.